Here we have a SAT math problem. Okay, let's go to the question. In an xy plane, the graph of the function f of x equals to square root of a times x positive b passes through the point 0, square root of 35. If both a and b are positive integers greater than 1 and a is greater than b, then what is the least possible value of x? Okay, from the given information, we have to find the least possible value of x that we have in the given function f of x. Okay, when we have the graph of a function f of x in an xy plane, so this f of x represents the y coordinate, that is y value. So we can replace this f of x by y, then the given function will become y equals to square root of a times x positive b. And also the question says the graph of this function passes to the point 0, square root of 35. Since the graph of this function passes through this point, we can plug in this x coordinate 0 for x over here and y coordinate square root of 35 for y over here. Okay, let me do it. Then I'm getting square root of 35 equals to square root of a times 0 positive b. Okay, then we get square root of 35 equals to square root of 0 positive b is just b. When I multiply this a and b, I'm getting square root of ab. Okay, now to get rid of the square root on both sides, we can square both sides. Let me do it. So when I square both sides, the square root will cancel. The same thing on the right side as well. So I'm getting 35 equals to ab. That is, I got the result a times b equals to 35. Okay, now let's get some values for a and b, so that a times b equals to 35. Let me do it. So let me take a over here, b over here. If I guess a equals to 1, then b has to be 35. If I guess a is 35, then b has to be 1. If I guess a is 5, then b has to be 7. And if I guess a is 7, then b has to be 5. Okay, so here I'm getting 4 pairs of values for a and b. So if I consider the first pair, I'm getting 1 and 35. That is 1 times 35 is 35. So like in the second pair also, I'm getting the product of the two values a and b is 35. So in each pair, I'm getting the product of the two values equals to 35. So now in these 4 pairs, we have to check the pair which meets the conditions given in the question. That is both a and b are positive integers greater than 1. At the same time, a has to be greater than 1. Okay, if I consider the first pair, the value of a is 1. But the question says both the values of a and b must be positive integers greater than 1. So we can reject the first pair. So we can reject the second pair also for the same reason, because the value of b is 1. B has to be a positive integer greater than 1. It cannot be accepted. Now let's consider the third pair. Okay, here both the values of a and b are positive integers and also greater than 1. But this particular pair does not meet the second condition. That is, a has to be greater than b. But here the value of a is 5, b is 7. The value of a is less than b. So we can reject this one. Let's consider the fourth pair. So here both of them are positive integers greater than 1. And also the value of a, that is 7, is greater than the value of b, that is 5. So this particular pair meets both the conditions. That is, both a and b are positive integers greater than 1 and also a greater than b. Now I got the values of a and b, that is a equals to 7 and b equals to 5, where the product of this 7 and 5 equals to 35. And also the values of a and b over here meet the conditions given in the question. Okay, next step what I'm going to do is I'm going to plug in this 7 for a over here and this 5 for b over here into the given function. Okay, let me do it. So f of x equals to, let me plug in the value of a, that is 7 times x positive. Now let me plug in the value 5 for b over here, then x positive 5. Okay, now we have a square root function. Whenever we have square root, the value inside the square root has to be either 0 or positive. We can never have a negative value inside the square root. In case we have a negative value inside the square root, then it will be considered as imaginary. In that case, f of x will be considered as undefined. If I want this f of x to be defined, then the value inside the square root on the right side has to be 0 or positive. That is 7 times x positive 5 greater than or equal to 0. Actually, this is the domain of this function. So domain is the values of x for which f of x is defined. So here f of x is defined when the value inside the square root, that is 7 times x positive 5, is greater than or equal to 0. Okay, now let's solve for x in this inequality. Okay, let me divide both sides of this equation by 7 to get of the 7 multiplied over here. Okay, when I divide both sides of this equation by 7, this 7 will cancel out. Then I'm getting x positive 5 greater than or equal to 0 divided by 7 is 0. Okay, now let me subtract 5 from both sides. When I do so, this positive 5 and 85 will cancel out. Then I'm getting x greater than or equal to negative 5. That is, when I combine 0 and negative 5, I am getting negative 5. So I am getting the result that x can be equal to negative 5 or the value of x has to be greater than negative 5. So from this inequality, it's very clear the least possible value of x is negative 5.